Let's solve the following problem, which asks us to sketch the following set in the complex plane, and this set is denoted by capital B, and it consists of complex numbers such that they have arguments equal to -π/3 and modulus that is strictly less than 1. So let's consider these two conditions, two constraints separately and try to sketch them in the complex plane. And what we have to do then is to take the two things, two shapes that are defined by these constraints, and since both have to be satisfied, we have to take the intersection of these things. Okay, so let's do the sketch. Here is the complex plane, the real and imaginary axes. Now we need some units, so let me say that here is 1 unit of distance, should be good, -1, +1, again -1. And the idea here first is to look at the argument, the angle of the complex number in the complex plane that goes from -π to π. These numbers should have an angle of -π/3 radians, which is -180 degrees divided by 3. That's -60 degrees. So that should roughly be, so take the positive real axis and downwards we should have -60 degrees, a line coming off in 60 degrees. So this is -π/3, this angle. And all points along this half line have an argument that is -π/3. So all numbers along this half line satisfy this relation. Now, what are the numbers that satisfy the second relation? Well, we just have to look at their argument, their moduli being less than 1. Well, what are these numbers? The numbers that have moduli equal to 1 lie on a circle of radius 1. My drawing is not going to be perfect, but I hope you get the idea. So these points all have a length, distance from the origin that is equal to 1, but what we are interested in is the numbers that have moduli that are less than 1. So they are closer to the origin than 1 unit of distance. So it's this closed disk that we have to consider. So all numbers inside this circle satisfy the second inequality. So if we want to sketch the set B, we have to take the intersection of these two regions. So to take the intersection of the disk and this half line, well, in the disk is the boundary is not contained, so this point is not contained in B, but everything inside the disk that is along this line is contained. So B is this line segment with neither of the two ends belonging to it. 0 had to be excluded because for 0 the argument is not defined. Okay, so this is the set B.